welcome back, mathematicians. This time we're gonna do factoring by groups. I know some people have already started this. Not gonna say why I think they started this, but fact of the matter is we haven't gone over it yet. But this is another way of factoring, and again we're just kind of undoing that distributive property. Okay, so factoring by groups is I'm gonna look for certain patterns, right? So I notice this first section and the second section. And sometimes I have to reorder things. In this case, I'm not too bad off, but sometimes I have to put things in different orders. But for right now, I notice the first section and last section look very similar. Okay, so usually what I have to do is I have to factor out a few x's, right? And if this doesn't look like some kind of pattern, rearrange some stuff. Sometimes you have to put this term here and this term here, and then it all works out. Okay, so it's a little bit of a puzzle, but those are the best kinds of problems that we have. So for now, we're in good shape. What I'm going to do now is just rewrite things. So I'm going to put this guy in a negative x minus 4. All I did was rewrite things. So this is a plus, a negative, and plus a negative 4. And that kind of gets us into some kind of groups. And what's going to happen is we're going to factor out some things, and we should get the same terms in here in both factors, and it should be nice and easy. So I'm going to factor out, in this case, an x. Oops, that's supposed to be squared, so I'm going to factor out an x squared. That should make things work a little bit better. And that gives me x, just the first power, again, because I'm taking two of those factors out, plus 4. Again, I shouldn't have any more x terms, because I factored x squared out. Then what I'm going to do is I'm going to factor out a negative 1 out of here, and that should make this negative x minus 4 into an x plus 4. Okay, double check if you don't believe me. If I redistribute that, I should end up back up here. Okay, so I'm just kind of doing the anti-distributing, right? And then, look, I have two terms right here that are exactly the same, which is exactly what we wanted. So I have two terms that are exactly the same, right here and here. So let's draw that one first. That should give me an x plus 4. And what do I have left over? Well, let me get my black back. X plus 4 times x squared minus 1. And there you go. That's mostly factored, okay? On a test, I want to accept this as a complete answer because we can't forget we can still find the difference of squares here, right? So the difference of squares says that if I have a square here and a square here, and 1 is a squared, 1 times 1 is 1, so that is a square. If you don't remember your squares, take a look back at your notes. I think we did it in class, but if you don't, here's a list. 16, 25, 36. That's 6 times 6, so 7 times 7 is going to be 49. 8 times 8 is 64, 81, and these are more common squares. I would encourage you, especially if you're getting ready to take the SAT or PSAT, that you go past 12. I think next one, 13, I think it's 169 and 196, and sometimes you can go more, but again, if you're taking a PSAT, this is probably about the where, maybe one more, and you should be good to go. So anyway, difference of squares. I should get two terms out of this. X plus 1 and x minus 1, okay? And if you don't believe me, again, check it, please. These two terms, this term and this term, should multiply when you use distributive property to this guy. And this guy I just wrote straight down, okay? So this is a completely factored term, okay? I'm not saying that you should have x to the first power every single time, because if you look at some of those difference of squares, difference of cubes and sum of cubes, sometimes we don't have those square terms, or we do have those square terms in there. We don't always have just a x term, but double check to make sure that that's not the situation, okay? Thank you for listening. I'll catch you at the next one.